Okay, finishing up lesson 2.1 and really just reviewing quite a bit. For example 3, here's a function, a parabola y equals 5 minus x squared, an x interval of 3 to 3.8. Find the average rate of change of y with respect to x on that interval. Well, I think we can very often look at the average rate of change at the top of the notes, and sometimes kids will wonder if they need to write f of a plus h minus f of a all over h. Certainly you may, but again, you could just as well realize that it's just the slope of the secant line, y2 minus y1 all over x2 minus x1. Now what I hope you can do very quickly is find that f of 3.8. If you plug 3.8 into that function just as well as you plug in f of 3, you very well could get 5 minus 3.8 squared is negative 9.44. Plug in a 3, 3 squared is 9, 5 minus 9 is negative 4. So in other words, we'd have 3 comma negative 4. We'd also have 3.8 comma negative 9.44. Let's go ahead and just do our y2 minus y1 formula here. That's negative 9.44 minus our y1, which would be negative 4. Divide that by our x2, which is 3.8. 3.8 minus our x1 is 3. So what we're going to see very quickly is this average rate of change is going to be negative 5.44 up on top. Down below, 3.8 minus 3 is 0.8. So very quickly we could take negative 5.44, divide by 0.8, and we'd see our average rate of change is going to be negative 6.8. So that's really our average rate of change, and that's part A. Now for part B, looking at the top here, as we're looking at that, this would be y average. Y sub A would be the limit as h goes to 0. We're going to look at this specifically when x is approaching 3. So, by the way, that's where a would equal 3. So, something that we need to start seeing at some point, and you could have used this original formula up on top with the a plus h. It's just that your a would be a 3. You'd see that we would get this formula 3 plus h inside. So if I were to find that function f of 3 plus h, we'd get 5 minus 3 plus h squared minus, I'll put some brackets over here, 5 minus 3 squared. And we're going to divide all that by h. And certainly we just have to work this all out. So what we get is, distributing 3 plus h to itself, we'll get 9 plus 6h plus h squared. We're going to have to distribute a negative in there. By the way, 3 squared is 9. 5 minus 9, of course, is going to be negative 4. You could just put that in here if you'd like. And then we just have to clean this all up. Let's continue to do that. Distributing up on top, we get 5 minus 9 minus 6h minus h squared. Minus a negative 4 turns into a plus 4. And I think you'd see rather quickly where we're traveling here. You can see that 5 minus 9 is negative 4. The negative 4 would cancel with this plus 4, and we'd have negative 6h minus h squared. Just as we did earlier on the front page, we could divide out an h. If I let h go to 0 right now, guys, sadly what we'd see is our numerator and our denominator would be 0. So if I divide out an h everywhere in our remaining terms, down below, of course, we'd have a 1. And as h would go to 0, we would see that we'd be at -6. Now I want to compare our two answers. You can see that they're not super far apart. Our average rate of change on a time interval was -6.8, but at a very specific instant of x equals 3, we'd get an instantaneous rate of change of -6. So different answers, and really this is how we could have proceeded. Could we also have just worked this out with respect to a, and then at the very end substitute a equals 3 in? We could, but I wanted to show you just as well that you can plug in a very specific a value like x equals 3 in the very beginning of the problem as well. Well, good luck on your homework, and this is just the beginning of our unit.